replacement females. You know, as far as some things we're interested in them. You know, if we've got more information on the cows and them, we can better select females that are maybe from the more productive dams within the herd. So keeping heifers from cows that calve early in the calving season and have not missed a calf. So the old saying of fertile cows produce fertile heifers, and there's a lot to that we can select for those cattle. The other thing is cow age, and it's a good predictor of a more reliable indicator of the productivity and the life of that animal as well. We can look a lot at teeth and age in those cattle, but if we do keep up with the age of those cows, we can certainly figure out, well, how long are they staying within the herd? And again, that length, the average length in the herd, we can relate that back to our production cost and the cost of generating those females. So lots of data measurements, and again, those are just some of the basics of a few of the measurements that we take. There's a lot of data out there, and ranchers keep up with a lot of data points, and it varies with operation to operation, and it varies from purebred to commercial. The purebred folks are certainly going to be keeping up with a lot more data versus a commercial operation. On a purebred side, some of the traits that are very important, birth weight, weaning weight, yearling weight, average daily gain and feed efficiency are becoming more and more important. Maybe hip height, scrotal circumference. Then we have all of our ultrasound measurements, our carcass measurements, maybe docility, length of time within the herd on the mature cows. So there's a lot of factors that go into trying to make some decisions. And again, lots of data points that we can look at. So now it comes into the data management and how do we keep up with that. And I've put the first one as a Big Chief notebook, and some of the older folks in the crowd may know what a Big Chief notebook was, but that's what I used back in elementary school. Was a red notebook, and that's what we wrote our homework and papers in, and so we did things on the Big Chief notebook. So just a notebook, it can be as simple as just a paper-based data management system. It could be as simple as a computer spreadsheet. You could create your own spreadsheet, and that really works best for your particular operation. And then we also have lots of good commercial cattle software packages out there that vary from the very sophisticated software that's maybe more in tune for the purebred producers to some that are a little more basic that are more for the commercial cow-calf operations. So the key thing on those commercial cattle softwares is you can download some trial versions and figure out which one's the best for your operation and works best for your needs, so that you could do some trials and just figure out which one works best for you. Something else that's always good to remember, and a key point is we've got to make sure as we're comparing animals, we look at contemporary groups. And a contemporary group is an animal of the same sex, breed type, that are similar in age and have been subjected to the same management conditions. And so we've heard the saying, we've got to compare apples to apples, not apples to oranges. It's the same thing goes true with a contemporary group. We're trying to compare the genetics of an animal, the performance of an animal, on a fair comparison there. And so when we do that, we're able to identify good and bad animals. And again, it's important to compare their performance to that contemporary group, what the average of that group that they came from. And then we can figure out, well, which ones are the best. And then you can generate what we term of ratios, which is where they relate within the herd that they came from, or maybe just specifically the ranch, and how this particular cow performed to the rest of the cows within the ranch, whether it be 20 cows or 1,000 cows there. Some of the adjustments that we'll utilize today and on your homework and that are utilized in ranching is some of the adjustment factors, specifically for birth and weaning weight. And these are the Beef Improvement Federation standards, and again, you can find these in the resource that we provided. And some of the things that we've got to think about on these adjustments is we've got to remember, as we're comparing and trying to make things fair, a 2-year-old female, a first calf heifer, you wouldn't expect for her to have as heavy a calf, be able to have as heavy a calf at weaning as one that's from a mature cow. Same thing is, we wouldn't expect calves, the weaning weight of calves from heifers to be as heavy as those from a mature cow. So we would begin to adjust those so that we can compare a 2-year-old, a 3 or 4, or a mature cow to one another. So as you can see, if we had a first calf heifer, a 2-year-old cow, we would adjust her birth weight up to a +8. Whereas the weaning weight on the males and females will be a little different because we know the males are typically heavier. So the male adjustment would be +60 and the female would be +54. Whereas if we compare those 2-year-olds back to a mature cow, which was 5 to 10 years of age, you can see that there's no adjustment there. So we didn't need to give her any advantage. A 3-year-old gets a little bit of advantage and a 4-year-old gets a little bit of advantage. Now as those cattle get older than 10 years of age, you can see we would expect their performance to decline some. And so we're going to give them a little bit more advantage as well. So those are some adjustments and standards that we would utilize as we begin some calculations. So the adjusted birth weight, and it's really in that adjusted birth weight, we're looking at the known differences due to the age of dam. And so we're beginning to compare those so we can compare those fairly. So if we had a heifer calf that weighed 84 pounds and she was produced from a 3-year-old cow, the adjusted birth weight would be 84, and we add in that 5-pound adjustment factor for a 3-year-old female. And so the adjusted birth weight would be 89 pounds. Now, if she was born from a group of heifer calves where the average adjusted birth weight is 80 pounds, her ratio would be 89 divided by 80, and we multiply that times 100, so she's at 111% of the herd average, or she's 11% over the average. So again, this means her adjusted birth weight is about 11.25% above her contemporary group average. So adjusted birth weight is pretty simple to calculate. Now the adjusted weaning weight is a little more difficult because we're accounting for differences due to the age of the calf at weaning, the age of the dam, as well as the gender of the calf, bull versus heifer there. So for example, if we had the adjusted weaning weight, calculating it of a Angus bull calf, the birth weight was 84 pounds, the weaning weight was 554 pounds, it was 220 days old, and the age of the dam was 4 years of age. So we would take the weaning weight minus the birth weight and divide it by the age in days, and that essentially gives us the average daily gain of that calf from birth to weaning. We multiply that times 205 days, so that's the standard weaning weight there, weaning age. We add back in the birth weight because we didn't account for it, and then we add in the age of dam adjustment. So for example, in this one, you would take 554 minus 84 divided by 220 days, multiply it times 205, we add in the birth weight, and we add in that 20-pound adjustment factor for a bull calf from a 4-year-old cow. So the adjusted weaning weight ended up being 542 pounds on this particular calf. So again, this allows for a more fair comparison among the calves adjusted for the same age of the calf and the age of the dam, as well as the gender of the calf as well. Thus, if we wanted to calculate, well, how does that calf compare to its contemporary group in calculating adjusted weaning weight ratio? So if we took 542 pounds divided by the 530-pound average of the herd times 100, that gives us 102.3. Or that calf was 2.3% over that particular group's average there. So it gives you a perspective of where he ranked among the other calves that were born in that particular herd. Another data point that I think is extremely valuable, especially into a commercial cow-calf operation, is pounds of calf per cow exposed, because it gives us an indication of weight, weaning weight of the calves but also reproductive performance. And as we discussed in one of the first classes, reproductive performance is extremely important to the operation. And it really, if you look at the economics, that we would place the most emphasis on reproductive performance within the operation. So we have to get cows bred, we've got to get live calves on the ground, and we have to be able to wean those calves and market them. And so pounds of calf per cow exposed is really just a combination of weaning weight and reproductive performance. And it's calculated by, if you take the total pounds of calf weaned out of the operation, divide that by the number of cows exposed to the bull. So if we had a 100 cow operation and we ended up with 42,500 pounds of calves from there, we would end up with 425 pounds of calf per cow exposed. Another way to look at that is if we had an 85% calf crop, 85 calves born, and the average weaning weight was 500 pounds, you would end up with the same number there. So again, it's a way of looking at the performance of those cattle and figuring out how many pounds each cow on average across that herd is going to be providing for you, because then you can begin to figure out, well, what that value is for that 425 pounds and then what it costs you per cow to generate that 425 pounds of calf, or however many dollars value. So that gives you your break-even costs there. And so again, that gives you just some basic calculations, and there'll be a little homework on that as well. There's a lot of other data points out there that ranchers will use depending on their operation, but that's a good starting point and just some basics of data management that we'll discuss in this class.